All right. So here we go. We're still in section 2.3. 2.3 we started yesterday. We talked about the product rule. The product rule. Today we're going to talk about another very cleverly named rule. Want to guess?
Quotient rule.
Yes. Quotient rule. There's nothing incriminating fell out. That's always good. It's always the last person you'd suspect.
Well, you want to suspect right?
See what you did there. All right. If we got what's known as a rational function. A rational function is going to have variables in both the numerator and the denominator. It would be nice if we could just say, oh, let's do derivative of the top over derivative of the bottom. But it doesn't work that way. The quotient rule is a little more complicated than just that. Not much more complicated, but just a little. Here's how quotient rule works. You want to find the derivative with respect to x of f of x over g of x. So your function has a top and a bottom is what it's saying. If it didn't, it wouldn't be a quotient, and there'd be no point in using the quotient rule. Your answer, maybe not surprisingly, is going to be a quotient. You're going to have a fraction for your answer, just like you had a fraction for the original problem. The first thing you do is take whatever function's on the bottom and bring it to the top. Bottoms up. So the first thing you're going to have right here is what then? G of x. And much like the product rule, we're going to multiply it by the derivative of the other part. So g of x gets multiplied by f prime of x. Unlike the product rule, it's not a plus sign in between the terms, it's minus. Nice catch. Anyone want to take a guess at what the rest of it is? Yeah, what you said. I'm going to write it the other order, but you're right. F of x times g prime of x. So the top is really just like the product rule. I mean, I think yesterday we did this term first and then this term second, but you could have, for product rule, you can do it in either order because you're adding them anyway. You can add in any order you want. So says the commutative property. You can add in whatever order you want. You stay up there now.
Is that the same one?
It's got a push pin in it. It's not going.
No, the other two posters no longer with us. Well, they are. They're just not.
It's in a different place.
Yeah.
Not bad.
The bottom, to get the bottom, you just
Delta x.
no. Thanks, but no. I didn't double check. It's not delta x. It's just g of x as is, but you square it. It's a little bit, it's not exactly an intuitive thing, but it's not hard to memorize. And we're going to have so many problems with it in there that you'll probably involuntarily get it memorized. So remember my college ID. Yeah. Well, it was in Roman numerals. They didn't have the Arabic numerals yet. Which makes it really hard to memorize. Okay. Example sign. let's find f prime of t, or if f of t equals 3t squared plus t over t cubed minus 1. So it's 3t squared plus t on top, plus t, t cubed minus 1 on the bottom. This is a quotient, so we're going to differentiate it using quotient rule. So we'll get a quotient for our answer. What do we do first?
The G to the top. G to the bottom.
Yeah, bring the bottom to the
Bottoms
top.
up.
Bottoms up. Yep. So here's the bottom. Bring it to the top. You get t cubed minus 1. I'm just going to kind of preemptively put that into parentheses, because that's going to get multiplied by other stuff.
It's gonna be a lot, right?
Yeah, some of them kind of get a little algebraic. The calculus isn't really the hard part, it's the algebra afterward. Times, now we want derivative of the top. What's the derivative of the top?
60 plus 1.
Yep, this first term, the 2 comes down, gives you 6t down to the first. And then plus, t, when you differentiate it with respect to t, is plus 1. Minus. Now we've got to do the top.
3t squared plus t.
Yep, just as is, 3t squared plus t
Times 3t squared.
times the derivative of the bottom. So yeah, 3t squared is just one term. That's kind of nice. That'll save us some algebra down the road. Yeah, and then to get your denominator, just take the existing denominator and send it to the second power. Of course, you need parentheses because it's 2 terms.
That was not. So how was it? The host that was in this?
Casper?
Casper, not very
Oh, yeah, got it.
That'd be plus 1.
Plus 1.
Let's clean this up a little, right? We're going to have a 6t to the 4th and a plus t cubed for the first 2. We're going to have a minus 6t and a minus 1. Everyone okay with those 4 terms? Here's the thing. There's a minus sign here, and there's going to be a minus sign in all these problems, because it's part of the formula. So, anything that comes after the minus sign has to be in parentheses. We're going to have to distribute that minus sign through.
Can you just distribute it now?
You can do it on the fly, I suppose, if you want. I'm not going to, but you're welcome to try. I've only seen one other person do it. Well, I saw him when he left, but I never saw him come back. The first loop here is going to be 9t to the 4th, and plus 3t to the 3rd. The whole thing's still over that good old denominator. We're almost there. Almost there.
Read figure out what t cubed minus 1 is. T cubed minus 1 squared, should we do that?
No, that's a good point. I wouldn't get too worried about foiling this out or expanding this in any way. You can just leave it as t cubed minus 1 squared.
Just for telling me before you did it.
Oh,